So thank you for joining. Not too many of you. Like, I don't know if other people are just sleeping somewhere. There's a nice space downstairs with sofa, so maybe they're just hanging out there. So the topic for today is going to be troubleshooting distributed system with AI and LLM, how to keep your data safe. I'm going to first introduce some of the concept of AI, LLM. I'm conscious that not everyone may have the same sort of knowledge around those topics. And then we're going to take a look at a project called Local AI together with Kate's GPT. So the distributed system we're going to be focusing on today is Kubernetes. So from people here, who is familiar with Kubernetes? Just one, two, okay. Well, that doesn't really matter. It's good. I'm going to keep it very light on Kubernetes then. All right, let's talk in. So my name is Nic Vermande. I spent probably the last 7-8 years on Kubernetes, doing stuff in various capacities, product management, technical marketing, engineering, all these kind of things. I'm currently the head of DevRel at SpectroCloud, and if you have any questions after the talk, you can reach me on any of those social networks. So originally, I submitted this talk because I'm scared. I'm not necessarily scared of AI or the progress of machine learning, deep learning, these kind of things. I'm scared of humans. I mean, not scared of you individually, but scared of humans as a society. Because I don't know if anyone has read this book. If not, I would definitely recommend it. For me, I mean, it's been a couple of years old. And big data is not something new. All that, what is new, we're going to see what is really new for a couple of years now. But it really opened my eyes in terms of big data patterns and really about bias, human bias, the specter of human bias. And I think this is the fundamental issue. We are all biased as human beings in a way or another because of our education, our culture, where we come from, our friends, all of that. And if you think about it, the problem is that machine learning relies on human-produced data. And since we're all biased, it means that the data we produce is also biased. So that also means that the models we're training, they have a good chance of being biased. Because ultimately, humans are responsible for the algorithm. Like a model is nothing more but algorithm written by humans that are trying to make the model behave as a human, right? So if you think about it, one of the applications, and actually it's not far from reality. I'm going to take a more concrete example in a minute that is already applied. But imagine that an AI is responsible to determine an appropriate sentence if you're accused of a crime. So supposedly accused, you committed this crime. So that AI will use a model that has been trained. But of course, the data that has been input as an input in that model will include things like age, education, skin color, where you come from, eventually your parent professions, and what your friends may be doing for a living. All those are input data are called features, and they are a key part of the model. And the role of the model is to make sure that by comparing existing data, it can predict the right outcome. So it's going to compare all those features to the actual output and calculate the output on its own. And the goal is to reduce the difference between the outcome, the actual outcome, and its own calculation. So bias is really part of that. So of course, you can play with some of the parameters, the weight and everything of the model, but ultimately, it will always have some bias. And this is really the risk here, I think. So it's like a fictitious use case, but there are actually more real use cases, like one in the US There's a predictive program called Predpol, which is called now Geolytica. And the goal of that program, so it's used by all the police departments across US, and they use the software analysis to predict where crimes might occur. So it's going to look on the area, and it's going to incorporate historical patterns, but not only historical. It's going to take a look at what population live into that area, and also include things like what are their education, what they do as a job. So again, having a strong bias, right? This is already an application. And it doesn't end up here. It's just the beginning. We all seen, like ChatGPT and all this Gen AI getting a lot of tractions. As a result, there is a democratization of large language model that we're going to define in a minute. So that means anyone, any company, any individual can access those models for free. And the risk is that it's amplifying the issue, because now they are not just for specialized fields. They are for everyone. So ultimately, the risk is to have a very polarized society. So now the question becomes, what can we do to avoid that? Well, as individual, of course, we're going to see some of the answer, from a society perspective, but as individual, what you should look at first is how you can maintain privacy and data protection to begin with. So of course, if you're using ChatGPT, all your data is sent, on the public API endpoint, which is not necessarily the best thing to do. And so today we're going to talk about local AI. Local AI is an in-place replacement of OpenAI APIs, leveraging a local model, and actually can leverage a lot of different local models, while at the same time maintaining this API compatibility. So that means you can use OpenAI API, SDKs, and programmability, and run any models you want as a backend, locally on your laptop or in a data center somewhere, right? So that keeps your data safe and ensure, privacy. So I've been, talking about AI a little bit, but just to set the stage here, I wanted to define the different notion, because I'm going to keep repeating those terms. So AI is really a discipline. Think about it as, math or physics. It's an umbrella term for machines mimicking human abilities, right? That's really the aim there. So machine learning, or ML, is a subset of AI, and they define algorithm learning from data to make particular decisions. And you train those algorithms, again, so that on the long term, by training the data, when the model wants to predict what a result is going to be as close as possible as the actual outcome, right? So deep learning, now we go one level deep into machine learning. It's part of machine learning, but it's inspired by the brain structure. So typically, machine learning are using neural network methodology. ML can use like linear regression. There's a lot of different algorithms, but deep learning really highlights neural networks. And then we have Gen AI, generative AI, even one step further, still using neural networks, but with a lot more neuron layers. And it's advanced deep learning, of course, specializing into natural language, and producing some sort of content. Can be text, can be images, can be videos, all of that, right? And for this, Gen AI, deep learning, and machine learning, they are using large language models. So LLM, we're going to see in a minute like some of the content that it has. But for the moment, just remember, it's really an application across Gen AI, deep learning, and machine learning. It's not something really new there. So how does AI work? Well, that's pretty easy. It's just like probably, I would say, maybe not high school, yeah, probably high school level when you learn this formula. So it just means that, actually, it's the opposite. Like, yeah, the output, which is on the left side, the output is a function of the inputs. And really the input is data plus label. So if you want to grow a plant, for example, and you have historical data on that, you want to be able to predict how tall the plant will grow depending on maybe how much sun it got or how much water it got, all of that, right? So the input is all those elements, and the label will be how much sun, how much water, all of that. It's labeled. And the output would be, okay, it's going to grow that tall, right? As easy as that. And then the function itself is the model. The function is essentially the mathematical model to help you predict the result. So it's like a generic model for AI. But how about generative AI? Same thing, except that now, instead of just predicting a result, you want to generate content, text, image, video. The model or LLM model that we are going to use are all pre-trained. Pre-trained means that you don't have to feed the data. You don't have to train the model to be accurate, right? It has already been done for you. So same thing, you have the data input. In our case, can be a question. It's generated text, and the output will be producing the content. So what is new? What has been like in the last couple of years is what we call, so these LLMs are most of the time what we call foundational model. So a foundational model is a model that has been trained with massive amounts of diverse data, like text, images, code. They've learned to perform a wide range of tasks, like generating text, translating languages, and being much more creative. So those models are a lot bigger. That's the first thing. So now the models are bigger. The second part, that is also recent, is the architecture they have. The architecture they have is called the transformer architecture. So this transformer architecture, in simple terms, allows you to determine the outputs by putting weight in the inputs so that it can gain context. So this is why this model type of architecture will allow you to create, if you start a sentence and ask the model to create a poem with that particular, starting with that particular sentence, is going to do something coherent. So all of that is enabled by transformers. So which has been, the architecture has been sort of created in 2017, 2018, so quite recent. Okay, with this being said, that's the foundation. What is local AI? So as I said, it's a replacement for OpenAI APIs with a choice of local models. So if you can see it on the picture, it's just the Python library that can interact with OpenAI APIs. So if I were to do that, it's actually part of one application I've built for educational purposes. And the idea is just to generate dad jokes using ChatGPT, right? So here, we just use the OpenAI client library. And this is the main functions here. You want to create a completion, and you just specify the prompt, the type of model. This one is GPT-4, and the maximum number of tokens, right? So if you do that, you specify, of course, the API keys and initialize the various components. It's going to work with OpenAI, right? You're going to get an answer, but using the OpenAI remote public model. If you have a local implementation of local AI and run this again, that particular endpoint, it's going to do the same thing. It's going to be compatible. So this is what I mean by today, if you're in a company that is already using OpenAI APIs, you can continue to use that, except that now you can guarantee that you will have data privacy and that it will run within your local environment without leaking any data. So a quick overview of the architecture. Local AI, at the front, it's exposing an API compatible with OpenAI API. And what it does, you can then load any model you want that you can download on the internet from Hugging Face or GPT-4All. The work that has been done in local AI is just to wrap the tool set to run those models, because those models, they need tool to load them, to run them, and to perform inference. So inference just means that you are asking the model to give you an answer. That's called inference. And this, for the models to be loaded and for the user to perform inference, we need those runners, or what we call backends. So local AI is nothing more but a collection of gRPC server that gives you access to those runners. So front end, we have the API endpoint. We have then the local AI engine, which is a collection of gRPC server. And then you have the models that you want to load. You can have more than one, right? You just name the model you want to use for the inference, and you could use that one, right? But still having the same API front end compatible with OpenAI. So you can just, experience with various models, depending on their accuracy, depending on the field you're working in. You can just try them out, but still your single program will still be compatible. So here, maybe a bit small, you just have an overview. It's just the point is we support a lot of different backends. So here on the left, this is all the list of the backends or the tool sets that are used to run models. And this is all the compatible models. So for every backend, you will have one or several models you can use that are dedicated to specific things like image, text generation, video, all of that, right? But still, again, why are we doing this? It's because it's running locally, and you can use different models at the very end of backend of local AI. So just to give you an idea, so this is April of last year. We are now, February? So now we reach, in less than a couple of months, we reach 15,000 stars. So we have a lot of contributors. So you can really try it out. And let's start. So here the idea is to, actually I think I need to, it's going to be a bit complicated, I think, this way. Because I cannot stop with the other view. So here what we're doing, so OpenAI is, local AI is exposed as a container as a released artifact, right? So the only thing you need to do is just run the container as is, and you can see that depending on your type of processors, so here I'm using AMD Ryzen 9 with 16 core, so it's going to be a bit faster. It's going to tell you which model is going to load. So all the models can be directly downloaded into the models directory, and here you go. You can start practicing and playing with local AI. And that's about it. You just run that particular container, and now you have an API endpoint at localhost port 8080. So the next step is using the API. So here, I'm going to go back to full screen here. So here, I'm just generating the payload for the API request, which is tell me a dad joke. And over a couple of seconds, maybe a bit slower than OpenAI, I just get the answer. So for that particular request, if I go back to the other view, the answer was, so I'm just asking a dad joke, and the dad joke is, why did the scarecrow win an award? Because he was outstanding in his field. That's a dad joke. Not super funny, but that's not really the point here. So it's ready now. But let's think about something else a bit forward. Like, it means you can also build your own local chat GPT, right, for your personal or everyday usage. So for that, again, it's not very difficult. The first step here is, again, run Docker Compose. And the Docker Compose file just has a couple of components. Here you have the models you want to load, so from Hugging Face or any other model. And then you just specify in the environment of the chatbot UI, which is the project that gives you the front end, a fake OpenAI API. That's basically it. It has to be there. It's a requirement, but it can be fake. Right? So actually, I want to show you. I have it running. So I've got my container there. So here I have both my local AI container as well as my chatbot container. And I can just go to port 3000 here. All right. So if I go localhost, of course, it doesn't work now. Oh, I didn't put the password. Did I? Yeah, OK. Yeah, here you go. So what is, I don't know, blockchain. So I'm going to do just a Docker PS here. So Docker logs that particular local AI container, -F for follow. OK, so now I just hit there, and hopefully I should see an answer. So now it's got the prompt. It's going to take probably 20, 30 seconds. As I said, it's not as fast as OpenAI because it's a consumer-grade hardware. And that's another benefit of local AI. It can use any consumer hardware. You don't need dedicated GPU. You can use GPU. Some of the models and the backend supports that. But ultimately, you can, oh, it's already there, actually. So same sort of answer as what ChatGPT would tell you, right? So yeah, you can easily create your own ChatGPT application. OK, next. Of course, now we want to apply this to troubleshooting distributed system and to troubleshoot Kubernetes. And of course, AI is better than human beings to do all this action, pattern recognition, predictive maintenance, like what is going to happen, given the specific trends, given my historical data, what is the next failure I can expect of that system. RCA, root cause analysis, security threat detection, incident management, resource optimization, all of that are valid use case for using AI and in particular Gen AI for distributed system. So what is Case GPT? Right, so Case GPT is a one-liner CLI tool to scan your Kubernetes cluster, diagnose issues, triage them using simple English or actually many other languages. And it has an interesting feature, which is allowing multiple AI providers. So the goal of Case GPT is to analyze your cluster, different objects running on the cluster itself, pods, deployments, all the Kubernetes objects, and tell you, OK, this is the error I get. But now it can also talk to a Gen AI backend to tell you potentially how to solve that particular issue, right? So one of the so that's an example here. So you can list, this is all the different backend it supports. So by default, it's going to be OpenAI. So there's local AI, some Azure services. There is a couple of other ones. So the first thing to do, we're going to add local AI. We specify the model we want. Remember, local AI can have several models. So we just specify the model. And now we can do Case GPT analyze. We specify local AI as the backend. And we just going to use explain. So explain means that we're going to leverage AI to tell us how to solve it. Right? So here in that particular scenario, it's going to tell us, OK, you have to do that. So here I've got an error with the wrong image. And then the wrong container image that I'm pulling is going to tell us, OK, check that you have access to that image is the right name, and a couple of other things, right? From single command line. That's the idea behind Case GPT. combined with local AI. But there's even better. So why not bring this into Kubernetes directly? So that means, how about running this directly into our cluster? So instead of running it locally, you could run everything into a cluster, so it's easier to audit and easier to share with your team as well. So the idea is to run everything into Kubernetes. So we're going to be running Case GPT into Kubernetes. We're going to be also running local AI in Kubernetes, everything in cluster. Right, so let me show you quickly how to do this. So I've got my Kubernetes cluster, which is running there. So I've injected on purpose a broken pod, and you can see it here. Oh, sorry, no one told me that I was not sharing. I have first to do that. So this is my Kubernetes cluster. This is the broken pod. You can see that I'm pulling a broken image, nginx 1.a.b.c, which is not working, obviously. So Case GPT is going to detect that, and for this, it's going to report it into a custom resource in Kubernetes, which is just an object that I've defined a custom type. So it's called, for Case GPT, it's called result. So the Case GPT configuration, I've configured it so that I've got local AI as the backend, you can see. You specify local AI as well as what is the service running local AI. It's local on my cluster. So it's going to be using this backend to generate the text on how to solve that issue. And now it has detected that there was an issue, and it's going to be putting this into a custom resource called result, and it's going to tell you that, right? So the error message appears to be written in English, blah, blah, blah. Based on that information provided, I believe the most likely solution is that there was a networking issue or authentication problem when attempting to pull the image, which is not necessarily super accurate, which means that, okay, let's try another model. And maybe with another model, I will have a more accurate result, right? That's behind the idea. But here we have everything into the cluster, which is a lot easier to scale, right? Because it's really specific to your cluster. So you can just run that into every individual cluster. All right, that was pretty much it. Okay, so just as a conclusion, what we've been talking about today, local AI benefits, data privacy, and model choice. So try it out. There's a variety of models you can choose, a plethora of them. Maybe there will be one that fits your particular needs. You can also fit custom model into it. Addressing AI bias, of course, we need much more tools than privacy. We need regulation, tools, education. We need potentially some repression as well. The field is quite new, but I doubt we are going to manage the bias issue with AI. So it's going to be an ongoing issue over time. Troubleshooting with AI is just about integration points, in my personal opinion. So we have Gen AI that will help you pretty much with everything. And local AI and other projects will just help you connect to the right model, right? So what you really have to focus on is the different models and just try them out. And of course, event-driven systems are a good candidate because of the information you can collect, right? So the more data, the better for your model. So just a quick call for action. Check out localai.io, casegpt.ai to get more information on CaseGPT. And if you want to get more information, you can also go to the Discord channel there and subscribe to the different newsletter. That's it. Thank you.